Good morning. Kind of fighting with my sound setup here a little bit. Technology. Okay. Today is the 7th of November, 2018. My name is Jeff. This is the nybbles.io daily programming stream. Well, daily-ish. And I'm working on Basecode, and I'm kind of pushing to get the parser done for the Bootstrap compiler. So yesterday we worked on the with statement, with expression. And the compiler now supports this part, which is good. But I did think about a couple of things that were maybe not quite right here. I'm just going to make some notes, though. So what we have to do here is have to, like, let's say you had with something at the very top, then you did with dot something. Well, in that case, that expression, we have to treat that just like we would any member access. We need to translate that into a actual regular member access, and that's not happening anywhere right now. Yeah, so I just want to make a note to myself about that. This thing's gonna drive me nuts. Okay, I'm gonna try my best to ignore that. Just sounds funny. Which, you know, hey, part of the, for the course for me. Hey, VoightComp Phil. All right, so this morning I thought I would start taking a look at this stuff. And then, as this stuff goes, so I started thinking about the range scenarios yesterday, and I realized a couple things. I originally was thinking that I could do a reverse by just swapping the order, right? So go from high to low instead of low to high. The problem is, so there's a bunch of ways we could do this, right? So range or X range could generate actual code. We could have it make an array. So this is similar to, I think, you just do maybe yesterday, put in chat, like a list comprehension, right? You could create an array from the range. That's kind of, I'd really like to avoid doing that. I mean, conceptually, that's what you can imagine the compiler would do, but to actually create a real array just for that purpose seems kind of wasteful. But we could do that, right? Range could generate an actual array, and then at that point, we're essentially just doing this thing, right? So if we did that, if we did the range, then range is a real code generative thing. And what I'm about to say about, you know, going from low to high and high to low doesn't really apply, because we'd be evaluating it, right, we'd be generating code for the generation of that, right? So all the parameters in here would be evaluated at runtime, right? Just like anything else, and that would be fine. But it's wasteful, right? Even if we intern the arrays, it's still, I don't know, it kind of feels wasteful to me, right? Especially if you had like dynamic steppings and that's the other thing too, like what happens when you have arrays that are built from variable ranges and things, then you're generating, even if the compiler can do a lot of that stuff to some extent up front. Now, again, like if you start throwing variables in here, it can't. Yeah, it's not super efficient. So what I was thinking I would do is range would be an intrinsic, it would be in the model, but it would not generate any code. It would just be a placeholder for these parameters. But then I got to thinking, okay, well, what happens if I have, you know, low and high, so that introduces an interesting issue. In the case that I'm thinking of how I would use range. Okay, again, if range were really an intrinsic that did something like generated code, then no biggie, right? Because we're gonna evaluate low, we're gonna evaluate high, and we can have a comparator in there that says, okay, which direction are we going? And that's actual byte code that would get generated, no problem. But what I'm thinking is that I would just analyze we'd have a range element in for, I'd look, oh, okay, is this a range? Yes, it is. Okay, then go into the range generator version of the for loop. Now, look at you know, the start, the stop, the step. The problem is I can't, the compiler isn't going to be able to evaluate that. The best it could do is substitute, right? So I could translate, if I do it this way, I can translate the for loop to something like 4x from low to high, step, whatever. And then it's a regular range-based for loop, but in that sense, I can't know, right, what's high and what's low. I can only assume that this is start and stop, and that it makes sense, right? So then at that point, the developer is entirely on the hook. Yeah. So that kind of is interesting. So one thing we could do, so I thought about this quite a bit yesterday. So let's assume that what I'm showing here, the reverse, is not correct. Let's assume it's always low, high, and then if we had a step, 2. So this is low, high, step. And I'm using variables here because it just helps to highlight the more complex case. All right, so here's what I thought of as a possible workaround. So we want to reverse this, then we could just have a reverse intrinsic. Same thing here. So that actually, I don't know, that's not too bad, right? It's very clear, right, what you're doing. You're taking a range, and you're saying reverse it. Now again, reverse here would be an intrinsic, and it would be a no-op intrinsic. And the compiler would just be looking for, it'd be looking for reverse, right? And so it would look for range or reverse. And then if it sees reverse, it knows what's inside here is a range. So then you could say, okay, well, should it be a separate, or should it just be two different kinds of, right? Should we do like what C++ does, like R range, right? Or just spell it out, reverse range. I mean, that we can do that too. Then we'd have range, X range, reverse range, reverse X range. And then we would, it's just, this is low, that's high, and then step, right? And they're always positive, right? The arguments here are always positive, and it's assumed, right, that this is less than that. And then in this, yeah, even here, that this is less than that. And if you swap them, then it's going to give you nonsense, right? Then I'm thinking, okay, that's not too bad. But having range, X range, reverse X range, is there a way I could minimize that? Like having to have, 4 intrinsics. And so then that brings me to something else that is maybe let's call it kind. Is named parameters. We haven't really done much with this. Now the parser is gonna take this, but and in the case of range, well, no, I don't want to say that. Because theoretically, the way I would like this to work is you can put this anywhere, right? It doesn't have to be the last thing. It doesn't, you could put it anywhere and it would work. Then likewise, these are named too, right? All these are named, and you can use the name on any of them. Well, because how useful is that, right? You think about it. It's not that it's not that untypical to have range-based for loops that are parameterized, right? Where you want to say, oh, like I'm iterating through something and I want to like jump a certain, the start and stop needs to change. Yeah, you could use while loops for that, I guess. I mean, linguistically, I could say that range is only literals or constant variables. Okay, fair enough. I could do that. But, I was just thinking through yesterday scenarios where I would want to use this. And I'm like, crap, I can think of cases where I want to range over something that's changing, right? I mean, that seems fairly, it's something that would come up a lot, right? And since I'm building it from scratch, I've thought, well, I should at least consider how I could build it in such a way that would support this scenario. And so everything so far that I'm explaining here gets us to that point, right? It gets us to a range. It's a compile time artifact. There's no performance hit, right, other than at compile time for doing this. You can have dynamic ranges, right? So you can put variables in there. It will work. They'll go in both directions. They can be inclusive and exclusive, right? So fully configurable, right? And we end up with one intrinsic range that just has optional parameters on it that can be specified by name in case you need to change the direction or the kind. And supporting named parameters like this is something I want to do, absolutely, regardless. So this is just like a mini test case for actually doing that. Now, what's kind of interesting about intrinsics as it relates to that is intrinsics are not procedures. They're intrinsics. They're little masqueraders. So they're just elements, and it's the argument call that is intercepting this, and or rather, I'm sorry, procedure call. I don't. Yeah, here's the map. Who's calling this? I think the so it's in procedure call in the AST evaluator. We say, okay, we have a name for a potential procedure. Is it an intrinsic? Yes, it is. Okay, then we're just going to use that intrinsic. And the arguments have already been passed in. So we have the arguments. What we don't have in intrinsic right now is something that defines the parameters of what an intrinsic looks like what it would expect. Now, they are subclassed right now, so theoretically, yeah, I gotta think about that a little bit. Like I can think of a couple different ways I could do this, right? But in actual real procedure calls, we got to do kind of the same thing, right? So I'm kind of thinking of them as similar, and how I could theoretically make them share the same implementation. So, yeah. Because what this lets me do is on range intrinsic. So let's do that. Let's add range intrinsic. And I never did any templates in this one. Go. Oh, I misspelled it. This is one of those words. Range intrinsic. Do it right. Okay. Intrinsic. Yeah, I should catch up. There it goes. Okay. I don't know what any of this should be. So, what type should it represent? Okay. I'll be here for another hour and a half or so. Yeah, I'm not sure what type this should be yet. Let me close that one. Let's see. Yeah, element builder. Make fill. Make range. Okay. Yeah, so the good news is at that level, right, plumbing in a new intrinsic is pretty simple. If I can spell. Spelling's important. Okay, so actually, sorry, I'm getting all sorts of weird audio feedback. I don't know. Did that help? Can't really tell. All right. Hopefully you guys can still hear me. Computers are complicated. All right. Where was I here? Let's see. Okay, so range is plugged in. The compiler will recognize range now. It'll take whatever parameters are in there. It'll dump them into the intrinsic, which is a start, right? So in our tests here, assuming inclusive and range reverse are valid, right? So I'm going to say kind is 1, and for reverse it's 1 and normal 0. So I don't have, well, what we could do, let's do that. Ooh, should I try testing enums? This is interesting. This is interesting. So I'm just thinking here, what could I do? How could I do this? Man, I'm spastic. I haven't really settled in my mind on I'm not a huge fan of uppercase. So then I could say range kinds exclusive. Range orders reverse. And if I didn't want to do the, if I didn't want to duplicate that everywhere, I could import the namespace so I don't have to do that. So let's do this. Let's rename our test case to for range. Nobody's using it. You can rename it. I promise. Stop. Just rename it. Thank you. Then we're going to do for arrays for apps. So I moved my enums up here. And technically, this is going to be a dot, not a. Okay, so we have 3 different test files for the different kinds of for loops. So we can work on them independently of one another. Then I wonder, like, I might actually like kinds are, I have, oh, inclusive exclusive, Jesus. Hey, FD God 92. Then I can do that. quite welcome. Yeah, so when you mention comfort, it is definitely not, like I am sitting on a folding chair. This is a camping table. It's a foldable camping table. This is very, it's barely functional, yeah. I'm not sure. I'm not sure when I will be able to, hopefully soon, return home. Okay, so what's nice about doing it that way, although it doesn't really let me exercise and fix my enums, but now I can do an import. I forgot what, oh, no, I'm not, I remember. I can import range kinds from support, import range orders from support. Right, because that was the other thing. This is technically I would have had to put support in front of it too. So okay. Let's see what the compiler does. Oh, it has to recompile. It kind of makes me wonder how valuable enums are in the language. Like I pulled them over because they exist pretty almost everywhere, but with namespaces and constant declarations, I'm not really sure. I mean, other than the auto numbering, aspect of it. Unfortunately, we're touching parts of the code base that force a rebuild. So it's been a while since I've tested import. It works, or it was working. And with those imported, these symbols are should be resolved without the extra namespace in front of it. And we added the range intrinsic. We added it to the factory map. And like I said, the parser should just turn this into a list for us, an argument list. Okay. What does it do? Oh, it blows up. Oh, because I never set the type for the... What type can that be? That's for the range thing. Hello. Money L. How's it going? It's going well. It's Wednesday. I'm going to do this just as a placeholder. It is not right. Fortunately, it's going to have to build again. I just realized I left the air conditioning heating fan on. Let me go turn that off, actually. I'll be right back. Ah, the ambient noise level just dropped. Okay, after I get done banging around here. Okay. Yeah, that lowered the noise level a little bit. I always forget that's on. Void comp fill. I think I made a massively incorrect assumption. Is proc evaluated at compile time or runtime? Compile time. Everything is compile time. Right? There's very, yeah. Unless you're talking about the statements inside of a scope, very little is, the minimum amount of work is being done at runtime, right? So, yeah, procedures are all evaluated at compile time. Why the sad Isaacs floating on? Yeah, this Basecode alpha is, there's no cheating here, right? I mean, I could do things at runtime, but I'm very hesitant to introduce anything like that if I don't have to. Oh no, Mr. Bill. So, uh-oh. I'm not even getting... Why didn't that evaluate? Context node. Right inside proc call. Range. You mean function calls, like actual function calls? They're implemented, but they're not complete or correct, really. And I'm not emitting that code at the moment. So, yeah, I don't, right now the compiler won't generate a call to a Basecode procedure. It'll compile a procedure, but it won't emit a call to it because for that stuff there's lots of stack scoping things that I haven't gotten to yet, and calling conventions and all that. So intrinsic functions are things built into the compiler. Some of them do generate actual bytecode, like alloc and free and Yeah, there's a handful of them, right, that generate actual bytecode, but most of them are compile time. They get folded as constant things at compile time. Like as an example, address of is not, it doesn't really generate any code. It just gets translated into an assembly label that gets resolved at compile time. Okay, so here's our argument list. Yeah, I mean, it's parsing all the parts. Why didn't it translate it though? Oh. Okay, so let's do this. Let's step into that. I think I might know what's going on. Maybe. Maybe. All right, so we're getting the range intrinsic. Yeah. So that was evaluating the block for the for loop. So what is this? Left-hand side here. Should just be, yeah, symbol, right? Yep. Yeah, if necessary, things would get resolved, yeah, later on. Do you know if in C++ there's a way to overload the way a struct is passed by value? It's interesting you bring that up because I was thinking about that very thing this morning. I was thinking about calling conventions and passing things by value or by reference, where reference is reference or pointer. The answer in C and C++ is no. You really don't have any control there. That's part of the ABI, that's part of the calling convention. And this is why sometimes people would write assembly language. If you really needed to have that level of control, that's what you would do, right? Now, GCC and or Clang may have extensions that let you manipulate that. I don't know. I'd have to look at the documentation. It wouldn't surprise me if they did have ways that you could potentially manipulate that, but the problem there, though, is it's not just a compiler thing, right? It's a compiler thing plus an operating system thing. And C and C++ have such a long history of being API compatible or ABI compatible there that I don't know if they actually offer any way of controlling that. Well, it's an operating system thing because if you look up, like for example, Linux, let me look this up. Linux struct 16 byte. Yeah, passing structs by value. So Linux itself has a thing, right, where internally its convention is if the struct is 16 bytes or less, Linux uses the System 5 ABI. There's a PDF for it. In the parameter passing section, it describes passing structs. Like struct is greater than 16 bytes. It'll always be passed in memory via pointer, but otherwise can be put in registers based on the rules on page 16 and 17. Yeah, so here. There you go. There's a PDF that describes it. So anyway, hey Raul Rita. Yep, trying to finish the old parser. So yeah, to Lori Master's point or question, it's not just, now here's the thing, okay? And I have been going through this mental exercise myself as it relates to Basecode. There's intra procedure calling, right? So thinking about Basecode here for a minute, Basecode procedures calling Basecode procedures, I can do whatever I want at that point. And C and C++, or any compiler really, inside of its own domain, you can have whatever conventions or control you want. Where that gets sticky, sticky wicket, is when you want to deal with the outside world, right? So if you have to call something in the operating system, if you have to call another C or C++ library or something, or anything that's compiled that would conform to the C or C++ ABI, then you have to be able to deal with that, whatever those calling conventions are at that point. Now, again, for Basecode, that's okay because I make a distinction between what's internal and what's external. The compiler knows that. So, like for myself, I think probably what I'm going to be doing is, like, the compiler is just going to, anything that's a composite type, so that's structs, enums, unions, yeah, strings, arrays, procedures, those all will always be passed by pointer everywhere because A, that's easier to deal with, but then that raises other issues too, right? So, yeah. Good old calling conventions. Sure, go ahead. Actually, I think if okay. this is probably not 100% correct, but better than what I had. Although this still isn't the, I fixed this because it was bothering me, but this isn't really the issue. The issue is in some cases that is not evaluating properly. J Dubik 100, what are you making? I am working on a compiler for a programming language called Basecode. And specifically, I'm kind of in a push here. I have 3 or 4 parts of the parsing infrastructure that are not yet complete for the language, at least as far as the Bootstrap compiler is concerned. And I am trying to get past those so that I can kind of more or less say, okay, the parser is, okay, yeah, that one's null, so why? I can say the parsing part is more or less good to go. Why is that blowing up? So let's do this. Okay, so the first one seems to be okay. Ah. Okay, the argument. We're not getting an argument list. Okay. Hey, Magnum Baguette. Hey, Stovoy. Thank you for the host. J Duix 100 says, sheesh, this is something you do in your free time? Yeah. Okay, so what is this? Identifier reference. Ooh. All right, what was that? Arg node. Assignment. Interesting, yes. It can't convert the assignments. Which makes sense because that's going to blow up, yeah. So I was almost right. The parser handles it, the translator isn't handling it. Lori Master has his paste bin. All right, so we have a struct with a pointer to some bytes, a 32-bit length and a 32-bit size, and then some stuff. Main. I see, yeah. Okay, and so then you're calling do something, passing that in. What the compiler apparently does. Yes, that is what the compiler most likely is doing. It's a copy, right? Ah, I see. Yep. Yeah. Yeah, and I would say if you're doing this on Linux or probably any Unix really, this is small enough, right? This is 9 bytes. This is small enough, it's just going to get copied. Okay, so here's my question to Lori Master. Is that C or C++? Okay, so if it's C++, let me ask you this. I mean, I know this is not what you're asking, but why not just pass the string by reference if it's C++? Then that gets you what you want, right? I mean, yeah, essentially to do what you want to do, not have a copy of that thing, you want to manipulate the same struct everywhere. I mean, for better or worse, the C++ answer to that is to pass it by reference. I mean, or you could pass it by pointer too, but I mean, if you wanted to kind of work seamlessly, and like in your example, passing it by reference would be the way to go. So Soyum 200 is asking if it's a copy, shouldn't it actually copy data rather than just assigning the pointer? So here's the thing, right? The answer to that is no. And this is, for those interested, this is the reason for Rust to exist, right? So, I mean, actually, Lori Master's example, which I know you guys didn't see, but I can reproduce something similar here. Let me actually come down here and create a new scratch. So let's say that you, so we're talking C here, okay? Let's say you take a, or C++, let's say you create a struct and you call it string t, and you have the data, and you have the length, and you have the capacity, okay? And then so if you create a string t foo. And in Lori Master's example, he's assigning it like this because you can, right? Because it'll do that. So here's the thing, right? Okay, so let's say I create another string and I call it bar and I assign food to it, right? Well, what is the compiler going to do here? I mean, what does it mean to assign a composite thing, a complex thing, to another complex thing? Well, the only thing you can really do here is this is going to be on the stack, right? The compiler can reserve more space on the stack so this is 5 bytes. Well, actually, no, I'm sorry, take that back. This is 4 plus 8 on this platform. So this is 12 bytes. So it's going to reserve 12 bytes. Now again, maybe it's putting padding and stuff in there, but let's just assume it isn't. It's going to move the stack pointer, and then what it's going to do is it's going to copy the memory from here to here. Now, here's the interesting part. What is it copying? It is not copying the data, right? It is copying the, and actually instead of doing it like this, I don't know, is it 12? Yeah. Let's just do it that way. We don't even have to put any data in it. So we're setting up foo and we're allocating memory on the heap, right? So then foo data is equal to a pointer of wherever those 12 bytes are on the heap. Now the heap is separate from the stack. So when we copy foo to bar, we are copying the pointer, we're copying the address, we're copying these two integer values. So now bar is a duplicate in this context of foo, except what happens if bar changes something, right? What if we say foo length is 12 and foo capacity is 12, but then we change bar length to 10, right? Well, is bar the same as foo? Are they the same thing? If they're the same thing, then you just broke it, right? Because that's not true anymore. Likewise, what happens if, like in Lori Master's case, you have a function that takes a string t and then does something like that, right? So we're going to call bingbaz and pass in foo, right? Well, the compiler, this is going to get passed as a copy, right? Because it's under 16 bytes. And now if I do stir len is equal to 10, well, what did I changed the copy, but I didn't change the original, right? And so then that's where you need to pass it by reference, because then if you do that, this is now modifying this because we're passing a reference, and the reference is the referent in C++. And you could do the same thing with a pointer, right? It's just different syntax, right? So anyhow, hopefully that explains. And so anyway, when I said this is the whole reason for Rust existing, right? What Rust does, this is where the borrow checker comes in, right? Rust says, if you try to copy this and it has memory somewhere else, that's, what does that mean, right? Because again, if you make a copy of this, it's not copying the heap allocated memory. It doesn't know to do that. So then what happens if the copy frees the heap allocated memory? The original doesn't know anything about it. So Yeah, fun stuff. So anyway, it could do better with dependent types, not in C++ though. Yeah, I mean, yeah, there are languages that have type systems that manage that stuff better. I guess the reason why I didn't want to pass by reference was not really a solution. Any function that takes a struct by value will still be undefined behavior and break everything. So either I remember to never use pass by value or I don't. Yeah, I mean, see that to me, this is like C and C++. That's just embedded in my skull at this point, right? When I write C or C++ code, if I'm passing a struct somewhere, I never ever pass it by value. I don't, right? I either pass it as a pointer or I pass it as a reference if it's C++. I mean, that's just something I always do. Now in C++, though not as much in C, because C++ compilers will optimize this better, I will return a copy of a struct because, like I said, the C++ compiler will do that, so it's not brain dead. In C, I almost never do that. I would just pass in a reference to or a pointer to a structure to get filled in. Yeah, and World's Ender does make a point. I mean, you could delete the copy constructor so that at least in that case, the compiler will prevent you from passing it. You'll just get an error. You still have to pass it by reference or pointer, but at least the compiler won't let you write code that is against the pattern that you're trying to follow. So in your struct, Lori Master, here, you had something like this, right? You had something like this. So if you did string t, const string t, other equal delete, right? So let's test that. Although this won't compile, shit. But yeah, something along those lines would be, this is the copy constructor. You also probably though need to, like, you have to be careful because the assignment is not the same. That's a different operator. But if you then did what you were doing in your example, had a struct, and then passed it as a copy by value to another function, the C++ compiler is going to see that this type does not have a copy constructor. It's explicitly deleted, and it will error. It will say, I don't know what to do with that. So unfortunately, you can't really make a copy constructor that does the right thing in this case, unless, no. I mean, you'd have to write lots of plumbing to do the right thing, unfortunately. Okay, where was I? Sorta, yeah, exactly, yeah. If you accidentally write the code that you are afraid you're gonna write, the compiler will bitch. Now, I'm gonna tell you, most of the compilers have really shitty error messaging when it comes to that stuff. So you're gonna have to kind of train yourself to recognize, oh, yeah, I tried to pass that by value and I shouldn't have. But it would work. All right, where was I? I was here, argument list. And You're welcome. David, the new kid, says, what educational software are you making for electrical engineers? I'm interested after reading the GitHub page. Which page were you referring to? I'm trying to remember. Sorry, I lose track of some things. So, Helium 200 says, couldn't he literally just write the copy constructor that does what the custom string allocator function does, though? I'm super confused. Yeah. Again, here's the thing. What you're not really controlling, though, so first off, copy constructor has to return a, it's a constructor. So it's populating a quasi-instantiated instance, right? It's finishing that process. So this that you're populating with a copy constructor, you didn't allocate it, right? So the system did. Now in C++, you could override allocators and there's things you could do there. But first, the very first important thing, the allocation has already happened. Right? By custom string allocator, I'm assuming he wants to control where in memory that thing lives. And so a copy constructor really isn't, by default, you're not really in control of that process. Now there's other ways you could maybe do it, but I think it would not yield the behavior that you would be expecting. Now again, there are things like, if you would take a look at unique putter or shared putter or something along those lines, you could build something like that, right? You could build stack auto wrappers around more complex allocated data. And those would manage that, and then those could be copy constructed and things of that nature, right? So that's how unique putter and shared putter do their thing, right? Unique putter does not allow you to copy it because of what it is. Shared putter does allow you to copy it, but it does reference counting as part of that process. So in this case, for his string type, you could either just have the struct, live inside of one of those or build something similar to it. So you could get to something close to what he's trying to do, but you'd have to do it in a C++ way, I guess is really where and I think he was trying to avoid doing more of that. Maybe I'm wrong, but yeah. Yep. Go pointers. Real pointers use 3 stars. Okay. So what I'm going to have to do, because the assignment evaluator, this has a very special meaning, and I don't want to change that. In the AST assignments, it's a simple structure, right? But and assignment, the assignment node is showing up in our argument list, which is fine. We're going to have this is going to happen in a bunch of spots, actually. And here, I think what we need to do is translate this to a we need to create a new element, right, in the compiler model, like property maybe, or named parameter or something. I don't know. And we take the assignment and we break it down into that new element here, and we put that in the list. Because it's the fact that we're calling the regular evaluator, we're hitting the assignment evaluation, and that's failing. That's the right tools for the right job. Assembly language for everything. I'm trying to think of what I want to call this. Because there's another place where this happens, right? Like here, right? These are assignments and they're parsed. The code I'm changing now is going to fix this too. But see, this is not, in some of these contexts, you can assign anything to anything, right? Which I want. So it's almost like a pair, but man, I hate that. It's too generic. So I don't know, I guess I could call it a parameter pair or an argument pair. Yay, I broke it. Let's see, J Dubik 100 says, just out of left field, can someone explain the difference between assembly and ISA? So an ISA is an instruction set architecture, and an ISA defines a memory model. It defines how instructions are encoded, how they're processed, right? So the ISA you can think of as the overall architecture and design of a CPU and how a particular CPU and how it interfaces with the outside world, right? But also internally how it functions, right? Like if you get the ISA documentation for x86-64, it's going to tell you how many pipelines it can handle, how many ALUs it has, how they can run in parallel. Right? It's going to tell you how it does stuff, not just here are the instructions. It's going to tell you what those things are doing and how they interact with each other. And oh, by the way, if on this particular ISA, if you issue this instruction, that's going to cause this other set of instructions to potentially not function for so many cycles because of this, and right, it's going to explain to you how everything happens. Assembly language is the distillation of the instructions, right, from the architecture, right, for a particular ISA. And it's just, assembly is the way in which you program that ISA at the absolute lowest level. If we set aside like microcode and things like that, right? Most people don't have the ability, or, it's just not possible to do that. But, so you can know assembly language for a particular ISA, but you may know the assembly language. You may not know much about the ISA though, right? So, and that is to say that if somebody said to you, how many cycles does this instruction take? Or if I issue these instructions in this way, what does that do to the branch predictor, right? That's where then you get the big thud of documentation from Intel or AMD or whoever, ARM, and you read through it and understand what those instructions are actually doing, how they interplay with each other. And the ISA, documentation definitely starts to trend more towards the hardware side of things, right? So you're really truly getting the deep dive on what's going on. So I don't know, hopefully that helps. Okay, unfortunately, this is where I'm probably going to have to end for today, but we are making progress here, slowly but surely. So I added the argument pair element, I added the plumbing and stuff I need to add to the builder for it, and then in that switch statement that I added to the argument list evaluator, we're going to pull apart the assignment and turn it into an argument pair in the case of an argument list. And that's actually going to fix that for everything where that happens, right? So for, you know, map constructors and all that other stuff for the struct literals, and it's going to fix it for all those. And then that'll get us back on track to the range intrinsic that I was working on, and getting that example, that for range test file, to at least parse and compile into the model. And then what else? Yeah, so then it'll be going to the for in statement or for in element and just starting to implement those to consume. Okay, does it have a range? Oh yeah, it does. Okay, let's start pulling that apart and interpreting it, and then generating the correct code for that scenario. Oh, yeah. Gotta add that. Okay. Map type had a warning in it. Yeah, it was this that I used. Okay, let's review these and what did I do? So in our CMake file, I've added argument pair to the model and range intrinsic. I took the 4 Basecode test file and broke it up into 3. 4 range, 4 maps, 4 arrays. We're going to be working on 4 range to start. Oh, and I also added some constants to the support module for the range stuff. So we haven't been able to fully test that yet because I have to fix some other things first, but I think we're going to be okay there. In the intrinsic base class, I added the range to the map, and then I added range intrinsic, which it's just it inherits from intrinsic, and it'll be pretty much the standard dealie. Infer type, I've got it inferring to an array type, which I think is what it needs to do, but we're probably gonna have to come and revisit that. In parser, I added a comment to myself. So the with stuff that we did yesterday, it's good, but I realized if we had nested withs that are doing dot member accesses, we need to do some binary operator coalescing here too. I'll come back to that. It's not super critical. Map type, I commented out align to eliminate a warning. And then for our test files, I just broke out the range testing, the map testing, and the array testing, so they're all separate. In elements, I include the argument pair and range intrinsic. Those are new. Element types, I forward declare argument pair and range intrinsic. I added argument pair to the element type T map, or type T enum class, and then added it to the name map because those are new. Element builder, added a make range intrinsic, and then implemented that. Pretty standard stuff. I'm gonna have to do the same thing for argument pair. Code DOM formatter, added argument pair in here. Then in the AST evaluator for argument list, did a little bit of refactoring cleanup, and then inside of the loop here, we have to switch now on the node type. We have to treat assignment nodes in an argument list especially. We have to create these argument pairs because we can't do the standard thing for assignment. It's not the same thing in this case. But otherwise, if it's anything else, then we just do the normal functionality that we already had. Yeah, I think that was it. Then added the new argument pair. So an argument pair just has the left hand and right side elements. So again, it's basically taking that AST node and transliterating it for the case of argument list, because we don't actually want to do much else with it. We want the left hand side and right hand side to be actual elements from the model, but the pair itself is just going to kind of sit in the argument list. So this is kind of bare bones at the moment. I'll need to do more work on that tomorrow. So I think that'll about do it. I'm gonna make sure I didn't break anything. Well, more than I already have. All right, push that up to the GitHubs, and that will do it for today. So I'll be back online tomorrow morning. We'll pick up and where I left off and continue on that journey. And yeah, I mean, getting range-based for loops to actually code gen should be fairly, like once we get this stuff worked out, the rest of this should come together pretty quickly because we've already built loops. We have while loops. So, you know, at the bytecode level, structurally, they're pretty similar. So it's not going to be, especially with range-based, right? We'll have an induction variable, but it'll just be behind the scenes, and yeah, so it should be pretty straightforward. So thanks everybody for dropping by. I appreciate it, and I will see everybody tomorrow morning. And yep, should be good. Bye.